All right, so I'm going to go ahead and look at this along with you here. I'll switch in devices, making sure this is all still working. Okay, looks good. All right, so as you can see here, I've just kind of drug out everything necessary to create this. So I've got my 4x squareds, I've got my 10x's, and I've got my units here. So if you weren't quite following what I was saying a moment ago, I didn't want to take it away from the screen that had the polynomial on it, is the long edge of the x is the same length as the side of the x, right? It's x squared. It's a square of the x. So those match up perfectly here. The short edge of the x is the same as the 1 because this x is 1x. However, there's not a specific amount of 1s that I could use to match up this edge. It doesn't quite work. You can see it's a little too much. And it's very ambiguous here, and that's on purpose because we don't know what x is. X is a variable, so we can't put them there. And then the same is true for the long edge of the x. If I compare that here, you'll see it's still just a little bit too long. So as we're putting these together, the more you work with algebra tiles, you'll learn sort of that's how it has to happen. And so as you're manipulating with it, you'll sort of see that happen. So if I just, let's say, take and start putting all these together like this, and then I try to fit my 1s where they belong, because they will match up here, you'll notice that doesn't really work. It's not a rectangle. So I've got to start manipulating. So maybe I'll bring these here, and I know I'm going to have to bring 2 of them. But that still doesn't quite work. So maybe if I bring a couple more down and start playing with it there. Well, now some of these are going to have to move here. Oh, there we go. So there's my rectangle. And now in this, the long edge of x is only touching x squared, and the short edge of x is only touching the 1. And of course, x's can touch the x's, the x squareds can touch the x's. And again, if this is something that's new to you, totally understandable there. But then from here, we can factor, and factoring from here is as simple as it would be with integers using an area model. We can just look at the edges of our rectangle, and on the edge of my rectangle here, this edge is an x and another x and a 1 and a 1 and a 1. So I could just bring these in to represent that. I have an x, another x, and then I have a 1, and a 1. So one of my factors here is 2x plus 3. And then my other factor would be this edge has an x and an x, and then another 1 and another 1. So my factors are 2x plus 3 and 2x plus 2 are the 2 factors for this polynomial. And if you want, you could write those out. You do the distributive property to check it, make sure it works, and it will work because we're looking at a rectangle that's made up of those pieces. And then, well, a rectangle is base times the height. And so we're looking at the base and we're looking at the height to find that there. So I'm going to go on a couple slides here so that I can start sharing with you a couple other resources that I want to share. If there's any, while I'm kind of resetting here, if there's anything that you want to share in the chat or any further questions that you have, now would be a great time to do that. A little moment of transition here. All right, so some things to consider. Um, and use the chat here. Let's share and collaborate a little bit more. And if you've never used algebra tiles, maybe this is a little difficult to answer. But just thinking in general, compared to the concrete tactile manipulatives, how is this the same? And that may be good, that may be bad. And then the second part of this question, you can answer it all at once, or you could enter a couple different times in the chat. How is it different? How is it different for the better, and how is it different for the worse? Yeah, so assessing remotely is a little different. You know, we like I mentioned earlier, we can't just look at their desk and see what they're doing. But if we pre-teach for that, and we prepare and we're intentional, and we set some things in place where students know that if we've given a task to do with a virtual manipulative, that you're going to have to take a screenshot and submit it to this place, and this is part of the assignment. It is a couple extra steps there. But it is certainly better than the alternative, which would be that that there's nothing. And yeah, I think the same. It's mostly the same. If we think about this SAMR model, like I said, this one is mostly in that substitution realm. There's a little bit of augmentation. There are some new features at the most basic level. Again, is just access. There's a lot more. We essentially have an infinite amount of algebra tiles. Manipulation of them in some ways is easier, in some ways is more difficult. It can be a little more cumbersome to have to click and drag than to physically pick it up and move it. But there are some features there that because it's virtual, again, like the infinite amount of them, that makes it a little better. In just a moment, I'm going to show you another, very briefly though, because it's free for now. It's not free forever. So it's not totally in the realm of where I said everything that I'm going to show you today is free. It is free for now. That does have some algebra tiles that are a lot more heavy on the augmentation side. A lot more features on this resource that definitely are improvements because of the virtual world. All right, so back into sharing. Something I just want to share real quick that I think is really important. So we talked about sharing screenshots, and we just brought that back up again. And I think that's important. We want to be able to see what the products are that students are sharing. But great mathematicians know that the math isn't in the product. The math is in the process. And just seeing a product of the end result isn't necessarily what we are going to need. Now, if it's students that are in our classroom interacting on the device, we can still see the process. But students that are at home, certainly we don't have the exposure to the process. We don't have exposure to that piece of their learning through just a screenshot. Now, I'm not going to dive into this. I just want to kind of name drop and briefly show you, and then you can look into it deeper if you want. But I want to show you a solution to that. It's a pretty popular Google add-ons, or a Google extension, so you may be familiar with it already. And it's called Screencastify. It's not something you have to download onto your device. It's an extension for Google Chrome. And then once it's on there, you will see a little button at the top, and I'll jump out of presenter mode in a second and show you. You'll click that button and click record. It's easy as that, 2 clicks. And it records everything on your screen. And so students could actually record their process. And then just a couple clicks, they're done, and they can then share up to a 5-minute video with you. They can go longer if you have the paid version of Screencastify, but the free version is unlimited 5-minute videos. You can't just put it on your device. Students would have to have it on their devices as well, but it does give you an option. This isn't something, if I were in the classroom, I wouldn't do this a ton. I probably wouldn't do it at all for students that were in my room, like brick and mortar, physically in my room. But if I need to see occasionally the process or a student working that's virtual, Screencastify is a great way to do that. And just real briefly, once you put it on your computer, so if I'm in Google Chrome and I just search Screencastify, usually the first thing that comes up, I've already installed it, but you would just click this button right here. It's that simple, then it's installed. And then it will show up, hopefully you can see in the top right-hand side here, right next to where I would type in an address, this little red arrow. When I click that red arrow, it'll allow me to just click record, and then it's going to start recording everything. You may have to allow it access to your camera or to your microphone, but it's going to start recording everything. When you're done, you repeat that process. You click on the little button again, and then you'll click stop. And then as soon as you click stop, it's going to give you some options for sharing. As soon as you click stop, the window will look like this, and you'll see on the right side here, we can share to Google Classroom, publish to YouTube. You can get a code, or you could even, in the most basic form, just download that and then share that. And as long as you have Screencastify as well, students could just download that, the Screencastify version of the video, share that with you. It's a much smaller file as well compared to downloading, say, a whole MP4 file. But that is an option. You can look into it further if you need. But I did want to recognize that products are great, but sometimes we need more than that. Sometimes we need the process. So there's 3 more that I want to show you. We're going to kind of briefly look at. The first one is Braining Camp. And so Braining Camp, I'm going to go ahead and paste in all 3 links into the chat. So as we get there, you can navigate to each of them. Braining Camp is the one that I said has some really great functional improvements. However, it isn't really free. There is a 30-day free trial, and I've been playing around with it a little bit. It's got some what I think are very well worth it functional improvements. The paid version isn't that expensive, but if it's something that you play with and then you start to really like it, it may be worth a conversation to have with your principal or even your spouse if you're gonna buy it on your own. I wish I could say that I never had to buy anything for my own students, but I think we've all been there. So Braining Camp, I'm going to open this up. I'm currently on my free trial. You can, I think you can just sign in with Google, which is what I thought I did before, but maybe I didn't. All right. So you'll see it's sort of similar. It's laid out a lot cleaner than the CPM site, but sort of similar in that we just have some different resources and some different apps here. And so I want to show you the algebra tile one and show you some of the functional improvements that I think are really great here. So first of all, we have different views. I'm not even going to touch the tiles yet. Down here at the bottom right, I've got this basic view. That's like what we had before. But I can also look at what they call the solving view. It's going to give me an equal sign and a little line here to divide the 2 sides of my equation so that I could set it up like I did when I demonstrated for you earlier. But this makes it a little clearer for students to see. And then there's also a factors view that sort of sets up the factoring and the distribution like we just did and helps students organize around their thinking there. And then another change to the view, we can also subdivide the screen, which is really, which I think is really great. And then a couple other functional improvements here. They will actually inverse tiles of each other, say like an x and an x squared. If you drag them onto each other, they will cancel themselves out, which I think is really great, especially if you're using the algebra tiles to solve equations. So that's really cool. All of the inverses, the opposites, will cancel each other out if you drag them onto each other. A lot of the other features are the same. They will snap to themselves, which I think is great. Changing the signs, if you click on the tile, you get some options where I can rotate, I can invert the sign, I can delete it. Something I really like here is we can copy. So like I could drag and select all three of these and then copy it. That's another great functional improvement. I can't copy and paste in real life, but here I can. So that's really great. I don't want to spend too much time on this one, though, because, again, this one isn't free. This isn't something you could continue to use forever. Another thing that I really like about this is it includes, you'll see here, this little idea button. Lots of amazing ideas on how you could use some of these in your class. So you'll see I've got a visual representation of slope, showing how we could model that for students is great. For my 7th grade teachers out there, we have the formula for area of a circle and kind of how that is derived from a rectangle. Beautiful representation of that, showing you how you could use this tool in that manner. The distributive property, I mean, lots of really great ideas in different ways you could use this. And some of this you could just steal ideas for now, sign up for a free account for the next 30 days, and then find other free resources like the one on CPM to use to model the ideas that you've gotten from here once your free trial sort of runs out there. But again, I just wanted to quickly show you this one. That link is there. I didn't want to spend too much time because it is one that isn't totally free. Now, the next two, GeoGebra and Desmos, I want to show you these two feature that will allow you to interact with students in a way that none of the others will. And these resources really get into the modification and the into the modification and redefinition of the SAMR model. And so to do this, I'm actually just going to kind of treat you like the students for a moment. We're going to do some activities so that you can see what it's capable of. You'll be able to, on your own tab, interact as a student, but then I'll leave my teacher view up so that you can come back into Google Meet and see that for yourself. And then on your own, you can kind of continue to play in GeoGebra and Desmos and see how that works there. So I'm going to jump into GeoGebra. Again, the link is there in the chat. There are thousands of activities here, and I wish I could tell you about every single one of them, but it's just overwhelming. I think on this resource, my favorite thing to do is to just kind of play around on this resource here. And so I'm going to I've got another tab here of one that I've already found and opened up for you. And so this, I want to show you just a little bit about how this resource works. So there's lots of different features in GeoGebra. This one was created already, and it's going to allow me to, I can manipulate and change the side of this triangle. I could manipulate this side of the triangle, and it's also letting me manipulate this angle. And then I can even trace the arc of this line here. So a couple different things going on here. But what I'm going to do is create a class. Again, this is free. You can sign in with Google. So I'm going to hit create class. And what this is going to do is going to load a page with a link and a code. And so if all of you will go to geogebra.org/classroom, and then once you get there, type in this code, you're gonna be able to interact with that task on your own. You'll be able to read the instructions and play around with that task. And then after, let's say 2 or 3 minutes of you just kind of playing with it, you don't have to actually complete the task and answer it right now. I want you to jump back into Google Meets, and I'll have the kind of teacher view brought up so that you can see what you're able to do as a teacher using any of the activities on GeoGebra. I'm going to type the code into the chat as well. So it's geogebra.org/classroom. And then the code is FDFYYAEQ. So it looks like I've got a couple in already. All right. So if you're working on the task, just take take a moment to flip back to the tab with Google Meets, and I want you to look at the screen that I'm sharing. So the screen that I'm sharing, and this automatically came up once I shared the code with you. I haven't had to do anything extra. You'll see that I can actually see the students that are in there based on the names that you put in. And then if I go down here at the bottom, I can actually click task overview. And then it's going to allow me to go in, and once anyone completes the task, it's going to show me the results. And there's an anonymize button that I love. It will change all of the names so that you can actually show student work to other students, and you don't have to worry. You don't have to worry about anything that comes along with doing that. So GeoGebra, again, full of things. I really couldn't do it justice even in a full 2-hour session. The biggest thing here with this one would just be to get in and play around with all of the different activities that are here. And these are really getting into the modification and the full redefinition of what's possible. So much of this would never be possible with tactile manipulatives. And then the last one that I want to show you real quick, and this is going to be similar. This is going to be another one that I really couldn't do it justice. I'm just going to have to kind of give you the introduction to what it is, and then you kind of on your own, homework, if you want to call it that, dive in, is Desmos. And that link is shared up there for you as well previously in the chat. If you go to just desmos.com, you get 3 options. You can go to their graphing calculator, which is really what they just started as. It's just a great online graphing calculator. And then students, if you create an activity as a teacher, and I'm going to show you how to do that right now, students would add in a code just like you did on GeoGebra and join that way. But as a teacher, I'm going to come in and browse activities. It is, again, it's free. You can connect it with your Google account. You'll see I'm already signed in here, and I just signed in using my Google account. It's totally free. On the left is all of our navigation, hundreds and hundreds and hundreds of great activities that range everywhere from the substitution all the way to redefinition in the kind of the breakdown of that SAMR model. But I've found one that I'm going to have us kind of interact with together. And so I'm going to open that up. And you'll see once, this may not do what I want it to do at first. Nope. Here it is. All right. So once you open that up, find the activity you're looking for, you'll have a few things. First, what I think is the most important is a student preview. This is where you can actually see what the activity is. So I can open this up and interact and see what would the students see. What am I going to ask students to do if I assign this to them? So there's a lot going on in this video. What different measurements are changing over time? So if I watch this video, I see we've got a guy who's climbing up stairs, walking, he sits down, and then he slides. Maybe he slides. He stops for a while, and then he slides. So students will respond to that. And then students are going to start, let's see, we're going to sketch the relationship. So I can watch the video again, and then maybe I could actually sketch out what's going on. So, it looks like time's going. So maybe I should draw this coming up. Oh, and then he went straight. He fell down. He's not going anywhere. And then he slides really fast. And then I could go to the next one and see what they're going to do. We could actually watch an answer happen. That's cool. And then it looks like we're going to get another series of videos where students are going to do that same thing. So this is certainly getting into modification and redefinition. This isn't something we could do with classic analog manipulatives. And then when I want students to do it, this green button here, create class code, you'll see I've already done that, but all you have to do is just click create class code. Then I can hit view dashboard. And then it's going to look a little similar to what we just did with GeoGebra. So if everybody will quickly go to student.desmos.com, and then you're going to type in this code. You can also share a direct link. So I'll put this direct link into the chat as well. And you can go to that direct link instead. Or you could go to student.desmos.com and type in this code. And then once everybody's logged in, we'll start to see some names pop up, and you'll be able to go through and work on this task. So once you get there, go ahead and jump back to this screen because we're going to start wrapping up once you get logged in. But I want to show you what you can see and what you can do as the teacher on Desmos. So I want to get a few people to at least go to the link and type in the code so that it'll populate some students for me. And again, from the chat, if you just click that link, that most recent link that I pasted in, that will do it as well. So if you're looking at the screen now that I am sharing, what you're seeing is all the students that are signed in. I can see, if you'll look at each of the screens it shows me how many students, this little 5 right here shows me how many students are on slide 1, how many students are on slide 2. It shows me what slides each student has been to. Once you've answered the question, it's going to show me whether or not you have answered it. If there's a correct answer, it's going to show me whether or not there is a correct answer. And then this also has an anonymize button. If I want to be able to share with students, so I can click anonymize, and it's going to make up silly fake names that will anonymize the class so that you can share student work and share student responses there. But again, to explore kind of everything that's in Desmos, you can just follow that link, that original link that I gave you, desmos.com. And this is another one like GeoGebra. The tasks are so varying that I really couldn't do it justice, even in a full 2-hour session. The best way here is just to kind of click around, play in the student previews, and see what is there to offer. But I actually have another session starting at 3 o'clock. So I'm glad that this is starting to wrap up. So I'm going to, I talked through a few slides there instead of actually having the slides up. So I just skipped through the ones I've already talked about. So let's just do a little wrap up. So in the chat, I want you to list, just in summary, some benefits, and then also, this is the real world. There are drawbacks, and I recognize that. Some drawbacks. So some benefits and some drawbacks of virtual manipulatives. So with one of the things that I really love about GeoGebra and Desmos, and the activities that are already created for you, is they range every grade and every kind of skill level for student. If you look deep enough, everything from kindergarten all the way up to calculus. And so just if you kind of look and play around enough on them, I think you'd be, I think even I would be surprised. I know I haven't certainly seen everything. It just how much ground could be covered with students using those tools, and they're free, which is amazing. And so as you're answering those questions, here's just a few things to consider that may help you think of some, some benefits and drawbacks, and things that I'm considering and would certainly be considering if I was getting ready to start teaching students this fall. As I was, if I were preparing to use some virtual manipulatives, would first be interface and devices that are available to me and that are available to students. Are they going to be using laptops? Are they going to be using Chromebooks? Do they have iPads? Do I have enough devices to be one-to-one or not? Student arrangement. Where are my students going to be? Are they going to be in my classroom? Are they going to be at home? Is there going to be some of both? Are my students going to be sitting at tables spread out in the room? Are they going to be sitting in desks spread out in the room? What is social isolation going to look like, and social distancing going to look like in the classroom? So arrangement, again, these are just things to consider, not saying that I have the answers for them. Equity, again, are students one-to-one? If students are learning at home, distance learners that are synchronous, are they going to have devices provided to them? If they do have devices provided to them, do they have internet access at home, even if they do have the device? So that's really important to consider as well. And then something to consider with the SAMR model is what level is appropriate. Sometimes basic substitution is what you need. If you're working with students that are familiar with algebra tiles and have used algebra tiles, then that might be great. That might be what you need. But as I think some of you discovered today, because you didn't have much background with algebra tiles, the substitution actually didn't work very well for us today. And I'm okay admitting that. It probably wasn't the right tool for this room, because there wasn't a lot of background experience with the algebra tiles, even though it was the most basic substitution. Something that was more in the modification or redefinition may have been more appropriate based on the background of the learners that are coming to you. And then again, the last thing to consider is just what's going to have to be pre-taught. How much pre-teaching are you going to have to do? Is it going to be basic technology skills? Are you going to have to pre-teach how to do screenshots or snips? Are you going to have to pre-teach how to use Canvas, if you're going to use Canvas for them to turn things in, or Google Classroom, Google Forms, whatever those tools may be? It's not just the use of the virtual manipulative that exists in isolation. So keep all of that in mind. So like I said, I've got another session starting in a few minutes, but that wraps everything up. I couldn't have planned this any better, I don't think, as far as time goes. So I'm glad that worked out. So I'm going to log off pretty quickly. But if you have any questions, again, I shared my email and phone number earlier. I'm going to share that again before I log out. And again, please feel free to reach out anytime. But thank you all for being here. And if you're joining me in the next session, I'll see you in just a couple minutes.